All right, I can't see anything. The guys weren't kidding. First thing is I wanted to say thank you to all of you guys for being here. Without you, it's not possible for me to be here. I get a lot of motivation from coming up here, being able to talk to you. Not only you guys, the guys out there, everybody that makes this possible. I wanted to say thank you. I was hoping we get one more round of applause, but for you guys, not for me. Thank you all so much for being here. I really appreciate it. I flew 15 hours to be here. I really appreciate it. So after the talks today, Alex at the beginning of the morning talked about reverse engineering. We heard some talks about variant analysis, and we also heard some talks about inter-process communication. All three of those are going to come in here, and so hopefully those talks serve you as a bit of a base to begin with. So what we're talking about is OSX privilege helper tools. My name is Tyler. I work at Cisco Talos. This is a required slide detailing what we do. We do vulnerability research. I focus a lot on Apple OSX type stuff, but we have people working on everything all the way down from kernel through Internet of Things, web-based APIs, everything in between. Everything I talk about today is blogged about there, except for the 0 days that I'm going to be presenting to you. Sorry, to be responsible about that, I do not believe these are high severity vulnerabilities. The person would need to have access to your computer to exploit these vulnerabilities, and so I feel comfortable releasing them to you. Okay, so an objective. First, we're going to talk about process isolation and the principle of least privilege. We want to understand inter-process communication and see the provided methods that OSX gives us. From there, we're going to talk about what is this thing what is a privilege helper tool, and then we're going to go over a bunch of vulnerabilities. So this is the idea of giving a process only the privileges that are needed to perform the intended function. The idea here is to reduce what an attacker is able to achieve upon its exploitation. One glaring example of this is I talked about Adobe earlier. We saw over 100 vulnerabilities submitted in Adobe, and so we know that vulnerabilities are going to happen, and they're pretty much unavoidable. But what happens when an attacker exploits something, and can we reduce what they're able to do? So this creates a need to raise privileges. The privileged processes are going to execute outside of the non-privileged processes, and then they're going to communicate via inter-process communication with each other. This can go everything from forking and communicating via pipes to Docker and Kubernetes, containerization, and many others. So here's a little example of what I'm trying to talk about here and how this has changed over the years. So we're talking about Safari. And Safari got a sandbox, let's say 4 or 5 years ago. So Safari is isolated from the system via sandbox. It also runs under a specific user called the Safari user. This particular user has very minimal permissions. So the sandbox and user are limited via the kernel. Okay, so you break out of the sandbox, you break out of Safari, you're still limited by system integrity protection via Apple. And then Apple is the only unlimited source here. And so unless you are Apple, you cannot modify certain functionality, certain files. And here is a list of the various things that are protected by system integrity protection. And so these are separated out. These privileges are separated out, and you're unable to access these. Okay, and here's the little fun thing I'm trying to do today. I'm giving away this bottle of whiskey to whoever is able to answer this question, and I'm looking for the first SIP bypass reported to Apple. The very first one. There was 3 people that reported it, one of them being me. And if you can find it, tell me the CV number. It's over $100 bottle of whiskey. It's yours. So just reach out to me after this if you're interested in completing that challenge. You can Google it, and it doesn't take any technical expertise to solve this challenge. Okay? So you have a non-privileged process, inter-process communication, and a privileged process, right? What we're talking about here today is this idea of what if an impersonated process or an attacker was able to communicate with inter-process communication. What this is going to lead to is the privileged process now needs to verify, is the person authorized and are they authenticated? For example, for a Safari process, you don't want random clients being able to reach out to Safari's privileged inter-process communication channels and communicate with them. And so that would be an authentication issue. If I was to reach out to a Safari IPC mechanism, the IPC mechanism should say, hey, you're not Safari, I don't want to talk to you. And if they don't do that, you'll see that it leads to issues. Okay, so we're going to jump into a few minutes of OSX inter-process communications. And that's starting really at the core design of a monolithic versus a microkernel, and how IPC is really at the core of fundamental of a microkernel. It's easier to look at via a slide picture. And notice how in the monolithic kernel on the left, all the IPC is built directly into the kernel layer. But in an attempt to make the kernel smaller, they moved this inter-process communication out into the application layer. And now all processes are communicating via this manner. And so this introduces the idea of a client-server model. The client-server model is where you have one process that listens continually, and you have other processes that connect to them and create bidirectional channels. And so this is very, very common on OSX and inter-process communication in general. So here's a big list of all the inter-process communication mechanisms. We're going to be focusing on mock ports and cross-process communication. Mock ports are very similar to Unix pipes. This is actually the stuff that's built into the kernel. So when you see the basic IPC there on the bottom, they're talking about mock ports. So it's unidirectional, one receiver and one plus sender. The kernel has direct access to these writes, and they are not sent out for any other reason. They're unforgeable, and mock messaging is the technology that actually utilizes this and builds upon it. We've seen many vulnerabilities related to mock ports. The vulnerability I asked you guys to look at was in relation to mock ports, and it's definitely a major area of security for OSX. So that brings up cross-process communication, which is built on top of mock messaging. And it's really just solely designed for this idea of the principle of least privilege, splitting out processes so that not every process needs to have all the same privileges as all the other processes. Hold on one sec. This is
Did you push out the HMI?
I did not. I was just going to try to go to displays.
We just good. Okay.
Nobody knows. I specifically came to the A/B testing too. Okay, well, while we wait, does anybody have the trivia question? 2015, okay. Who do we have an author? Do we have a person? I'm not sure that is the correct. That's about when system integrity protection came out. I believe. Say again. Okay, I'll look that up for you. I don't believe that's the correct answer, but I'll look it up. Thank you. I appreciate it. I'm sorry about that. Come on. There we go. Awesome. Thank you. Oops. I will discuss that with you after this, and I do believe you. And you can definitely have the bottle of whiskey. But don't stop looking. He could be wrong. All right. Okay. Cross-process communication, mock message-based IPC protocol. As I said, it's the way to split privileges out in applications, and designed by OSX. Okay, it's essentially a dictionary, a strongly typed dictionary, strict getters and setters, and it works off this server-client model that I talked about previously, due to the fact that it's a microkernel. And so what this means is that there is these processes that are on your computer that listen all the time. They're waiting for cross-process communication connections. So you would connect with them via Apple's provided APIs and send information to them. So at the bottom here is root pipe. In 2015, it was very, very popular. It attacked an internal XPC mechanism, an OSX internal mechanism. It had no authentication whatsoever, meaning anybody can connect to this call, and it took arbitrary data and executed it. And so remember that, because it's going to be very similar to what we're going to look at in a few minutes. Okay, and so here's a quick XPC client. We make a connection. We create a dictionary. Notice right below the dictionary, we have set int 64 with a key value pair. Remember, strongly typed dictionaries. Strong values, and then we send a message across, and it sends back a reply as well. Okay, and so now this brings in the last piece of the puzzle, and the puzzle is we have servers and we have clients. Well, who launches the servers? These servers are root, and so they have to be, they're privileged processes, and so they have to be launched by a root listener. And so Apple has this thing called launchd. Launchd is launched at boot, and it's the first process, and it's responsible for launching all other processes. The root user is able to register the process they want to launch via the launchctl command. You can also use that command to see what is listening. And so the daemons are stored in launch daemons, and the agents stored in agents. It is responsible for launching, and then it also keeps them launched. By default, the configuration, if you were to kill one of these processes, it would automatically relaunch it. This is being used as well for regular purposes as well as for malware. It's very often to see malware stuffed in these locations, told to auto restart, and then you're unable to kill them. You will see that again in a minute as well. Okay? And that brings up the privilege helper tool. So what is a privilege helper tool? It's a way to use cross-process communication and launchd for third-party applications. So a third-party application is going to put their software here in library privilege helper tools. They're going to register it with launchd, and they're going to sit there and listen and communicate via cross-process communication. So you're allowing third-party applications to sit on your computer and listen arbitrarily as root, and they're communicating via XPC. So here is a launchctl command listing out some of the files I have on my computer. The numbers on the left are the PIDs, and the 0 represents the exit code. And here is, again, some more privilege helper tools that I have on my system. Okay, a privilege separation mechanism provides the ability to separate out privilege functionality, and it utilizes the provided cross-process communication mechanisms. Okay, so one big thing as a vulnerability researcher is when you first look at these types of applications is you want to do a threat model. When I first started looking at this, I was in the middle of a big project, a big thing I was working on, and I decided to just do this for a little bit of fun. I looked at an application, I did a quick threat model of it, and now I'm here talking at this talk, and that's really all it took. And so I have a server that has the ability to change permissions of files, and it has the ability to execute commands. And I have a client that's supposed to connect to this. What happens if I am an arbitrary client and I don't follow the correct protocols, and I just try to call arbitrarily into the server? So now there's going to be 2 slides on Objective-C. There is a cross-process communication API built on top of C that is very underlooked at. It uses message sending rather than calling, Objective-C itself. And so it uses the class information and a method cache to give you O of log n lookup times to do this method calling. And so to give you a better understanding what this means, at the bottom there is a C function declaration of start process. And then here is an Objective-C declaration of start process. Notice it's strongly typed, just like C. It has named arguments, which is interesting. And then the usage there is a slightly fun syntax. And then in IDA, you actually see it's actually calling Objective-C message send and passing in data that way. So the function names are strings. And so like Alex was talking about this morning, it's very interesting because you're unable to strip the binary in any kind of reasonable way. And so the reverse engineering process is greatly aided by these string representations. Also, there's a special hashing functionality that it utilizes to correctly call the correct function. And we're going to talk about it more, but you can pass in nil to bypass those restrictions. Okay, and so that's laying the foundation. I'll just go over it one more time. We have cross-process communication, applications communicating with each other, and we have launchd, launching these applications as root, and we have servers and clients. And so the first one we're going to look at is this thing called Shimo VPN. This is the only OpenVPN client I looked at, but as far as I know, all clients based on OpenVPN are required to have this privilege helper tool. Okay, so when you first start reverse engineering, the init with mock service name is what's going to bind it to launch D and give it its name. We see com.fightgeist.shimo.helper. That's actually the name you're going to connect to. Then we have should accept new connection, dealing with the handling of the connection. And then we have what they call interface with protocol. And really, this is just a list of all the methods that are available to be called. And so it works very similar to RPC. Okay, should accept new connection, interface with protocol. You follow this in IDA, it leads you to a methods list. Also, I heard Ilfak was here. I'd love to meet you if you're around. It shows you the method list like this. Okay, so now we talked about our threat model. I can't really see very well, so I'm going to tell you the left side of the room. Does anybody have any idea what could be missing out of this piece of code based on the threat model we had? If you have no idea, that's totally fine. I was just guessing. But remember, we have a server who has to authenticate and authorize users. I don't see an authentication or authorization in this call. So it's arbitrary. It's taking arbitrary clients and connecting to them and allowing them to access the protocol. Okay? We're going to take a slight divergence and look at another application called AutoPackage. It installs arbitrary packages on OSX for you and see how they do it. So the same functionality, should accept new connection. And notice the very first line of the code says, is the connection valid? And then it says the protocol only if and when the connection is valid. What does it mean to be valid? It means that your code signer certificate matches the code signer certificate of the helper tool itself, meaning the person that signed the helper tool is also the person that signed the client. If you are not if the client is not signed by you, you should not be accepting connections from them. Does that make sense to everybody? Any questions on that? Okay, that's a core concept. Okay, so I showed you the protocol list. These are just some stripped out functionalities that I decided to look at. And the first one's run VPNC script with reason with reply. Okay, user argument passed in, user argument passed in, user argument passed in, and it's passed arbitrarily to launch. Okay, here is a quote unquote exploit to take advantage of this logic flaw. This is the protocol, the same protocol we saw in IDA. Some connection information, and then actually physically calling the method. I know it's a bit hard to read all this Objective-C, especially if you haven't looked at Objective-C very much. Looking at this a little deeper, notice in this particular instance I use what's called a block. Blocks are very similar to functions, but when they're used to handle return values, they're called closures. And then temp.root.py is just a simple reverse shell. Okay, and so now we're going to jump in and just see this first one in action. Okay, so you see that I'm not doing anything fishy. It's the same thing we saw before. You just put that in the temp, root up, chmod plus x, and then I didn't check the. Oh, oops, gotcha. That would have been the demo gods getting me again. Okay, so now we're here, and then we just open up our Xcode project. I'm releasing all this information. It's already on GitHub. You can check my GitHub out. It's there right now if you wanted to follow along. Okay, it's the same thing I just showed you, the same script, run VPNC script, and actually call it out. You just push play, and it builds. It might take us a couple seconds to run. Oops, I forgot to set up a shell. Let me set up a listener. So let's do it again. Okay, and then you type ps-jp. Oh, who am I? It's obviously the root. And then if you follow it back to see where it came from, you'll see that it came from Shimo itself. Okay, library approach helper tool, com, Vikeist, Shimo helper. And so this helper tool is sitting here listening arbitrarily and giving people the ability to execute commands as root. Okay, and so here is what launchctl at list would look like. And if you did it with, if you just want to see all the programs, oops. And so these are all the tools I have installed that are not from Apple. And you probably have a lot of these installed not from Apple as well. And so all of these have root privileges. The ones that have PIDs on the left, they're all listening services, and so they're all potential areas for problems. Okay. Now this next one was a little bit more interesting, or I thought was a little bit more interesting. So we have a code signing check here. And I talked about code signing just a moment ago, and code signing seems like the correct way to deal with these issues. So you have to code sign to verify the thing that you're actually trying to access is the thing you believe you're accessing. They're using an Apple-provided API here called SecStack check code validity with errors, and it takes a code and the flags. So going on Apple's website, we can see what these flags mean, and we see that the flags they pass in were 6, as you can see there at the bottom, and that means case-sec CS basic validate only. Do not validate executable, do not validate resources. Okay, well, what does that mean? Well, that means that authority, me, can sign a program, or authority, Apple, can sign a program, and they both are valid signatures. So we have an incorrect signature handling, and any signed binary can be used to bypass these checks. Okay, so let's see if we can get this one going. So I have shimo.zip, which is just shimo installed. And then what we're going to do is we're going to take that root.py I said, and we're going to sign it. And so I call it a raccoon. So because I'm going to replace their program with that. I do have to enter my name. I do have to enter my password. But this is my password for my keychain, not my password for my computer. And so then you just cp this raccoon into /temp. And then we're going to go to a new user. The only thing I've done with this user is simply log in one time. When you first log in, it has a couple problems. So we're going to take that shimo.zip I showed you, .zip, put it here, and we're also going to take that raccoon and put it here. Okay. Doesn't appear to be there. There we go. Okay. So that's Shimo itself. And if we go into the application is just a folder directory. It's nothing special. And we see these are all owned by the demo user. And we see the thing called raccoon there. To check a code signing certificate, you type code sign -dvvv, the binary you're looking for. And you'll quickly see the authority is Apple root, and the developer is Fabian Jaguar, the author of Shimo VPN. So what happens if I take that raccoon that I just had back here, signed by Bohan, and put it, and I replace the raccoon they had. Notice now it's signed by myself. When I launch Shimo up, again, this is the first time I've done any of this, so bear with me. Continue the trial. So the use case here is that if somebody had an account on your computer, or they were able to somehow get your account, they're still able to use these privileged helper tools because all users still have to deal with the same root file system on this computer, so that it's still listening here. I don't have root with this account, so I can't look at sudo launch CTL, but I can still see pgrep-ishimo, and I can also still do psjp, and I can quickly realize that Shimo is listening and available. So now you just pop open Shimo, go to preferences. There's a cute little raccoon that pops up here. You create, put some numbers in there, create a connection. It's going to ask for a share. Before we get started, before we have that happen again, it's going to ask for a pre-shared key, and you type OK. And again, very clearly, I'm root. And you can again see the calling process was Shimo VPN. Library approach helpers, config Shimo helper. Okay, did that make sense to everybody? I code signed my own application, I replaced their application with my application, and it bypasses the code signing checks.
That check basic API only checks with the binary.
Only signed whatsoever, with no verification on the team identifier or any of the properties inside of the code signing itself. No checks on any of these things, just the fact that it has a signature. Okay, and so that was Shimo VPN, and basically there was no authentication whatsoever, so anybody can call these functionalities as we've been seeing, and every single one of those things I showed you is vulnerable. All these are vulnerable. Between writing configurations, deleting configurations, loading arbitrary kernel extensions, unloading arbitrary kernel extensions. However, you actually cannot load and unload arbitrary kernel extensions on OSX anymore. And this is where we're talking about the principle of least privilege. OSX has actually removed the ability to load and unload kernel extensions unless you are a system integrity protected process or the user gives you explicit permission. And so it's another example of how by making the operating system harder, it actually makes vulnerabilities less valuable, even though they're still there. It's kind of the idea of not trying to find every single vulnerability, but make it so that you can limit their impact. Okay, outside of the code sign error, outside of the code sign problem, there's still an error. This guest user has no explicit permissions to be root whatsoever. He's not in the wheel group, he's not in the root group. And so if he tries to call something, calls out to a root process and says, hey, do something on my behalf, that root process should say, no, you don't have any access to be root. And if he needed to be root, then the administrator should grant him access to be root to use that VPN service. It should not be just arbitrarily handing out authorization to non-root users. So the coding guidelines. You first need to authenticate the client. This is typically done using a team identifier. And then authorization of the client. Is the user allowed to perform root tasks? And should I ask for a password? Again, we're going back to auto package. So we have a protocol, and we have a sensitive method, installing a package from a path. Sensitive method. The first thing it does when it reaches the sensitive method is it checks authorization based on authorization data that's been passed in from the program previously. Essentially, this has the ability to ask a user for a password if needed, and it can also check if the user is in the correct groups beforehand. And so these types of things should be done by these privilege helper tools before executing arbitrary commands. Okay, so we need to check the code signer certificate, and if a call requires privileges, utilize Apple's provided APIs to ensure the authorization of the person. Now, one of the issues, I believe, is this comes directly from Apple's coding guidelines, directly on their internet. And if you look at the second one down, I highlight purple to kind of highlight what the issue here is. It says a non-privileged process should first use authorization services to determine whether the user is authorized. Well, as we've seen before, it seems as if Apple does not think that somebody can arbitrarily replicate these communications. If the non-privileged process uses authorization services, but you don't have to use the non-privileged process, you can use your own process. And so I'm believing some of the issues may be stemming from a not clear guideline on Apple's site. Okay, talked about this. All methods are vulnerable. So then I talked to the people that work at Talos. I had 16 of these programs. 5 of them were vulnerable, 4 being full local privilege escalation, 1 malware thing. And so my goal with this talk is to reach out to a larger group of people, give it to you guys. And everybody that has an OSX computer, I'm hoping you can go and run these on your system. I know there's more vulnerabilities out there. I've seen them myself already. And so I'm hoping to kind of do crowdsourcing to get more people to look at these. Okay, we're going to go through a few more findings. So Clean My Mac X, it's a malware detection tool and like a system cleaning tool. No authentication or authorization, meaning you can call any of these functionalities. It's mostly revolves around removing things, but if you had some kind of virus protection or some kind of malware protection, you would easily be able to remove it with these functionalities. So talking about variant analysis, they did not correctly handle the problem. And why didn't they correctly handle the problem is that it's registered with LaunchD. As we spoke about previously, LaunchD is going to launch applications at boot, typically, and it keeps them launched. And so if you fail to unregister your process with LaunchD, then it still lives behind. This guy, Eric Bergerlund, has a small blog about privilege helper tools that have been left behind, dangling privilege helper tools that kind of just sit there and listen on your system. And so one of the examples I'm going to go over in a moment is one of these helper tools. I don't have the application installed on my system at all. However, it sits there and listens, even though it's not there. So we had a GOG Galaxy Games, which is like Steam game engine. In this one, I actually cannot demonstrate this because they have an auto-update functionality that doesn't allow you to use old versions. But it was able to create any folder on your system, globally read, write, and executable for all parties. As you can see at the bottom, there's a fake directory with all permissions given to it that I created via GOG. Okay, Wacom tablet, similar. This one was slightly more interesting. These guys, they actually tried. They really did try. They followed the direct idea of putting in only the things that you need to call. So it's very specific processes that they try to, so they ask you for the process you're getting from, and then they compare it to a list of processes they have on their system. And if it is one of the systems that they have, they'll launch it. Well, if we combine that with the previous GOG Galaxy Games vulnerability to create arbitrary directories and files, we can actually just get code execution from here. And the reason for that is they have a lot of processes on here that are old, and they access old file systems that OSX doesn't even use anymore. And so you can just create, if you had the ability, which you have to use 2 vulnerabilities for this, but if you had the ability to create arbitrary files, arbitrary folders, you could easily take advantage of this. Okay, and so as I said, I don't have the ability to do the GOG Galaxy attack, and so these first 2 commands use a sudo command and are an example of what that was while I was able to, when I had that as when I had that available to me. So you run it, it's going to ask for the password. And now if you check here, it's just going to show us that the permissions are changed, and all I did was copy in /temp./root.py as this file here. Same thing we had previously. We open the other chemopium. So the first example I'm going to show you just launches Android file transfer. This one just launches Android file transfer, and so you can overwrite arbitrary files on the root system. You can do anything you want with this. It takes say 5 seconds to there you go, to load our Android file transfer. Notice it popped up, and if we did pgrep-i Android ps-jp71342, you quickly see that's root launched by a root application. And then, so you could utilize that to overwrite arbitrary files on the system. And then from there, you can just run this, same thing we had previously, change the comment. And so you can launch, there's like over 15 applications you can launch with this. I didn't audit all of the applications. I just submitted the vulnerabilities. I'm assuming there's other vulnerabilities inside these. It got so bad. There were so many vulnerabilities that I had to call it at some point. As I said, this wasn't even I wasn't even planning to spend very much time with this. Okay, and so we see this comes from com.wacom.update helper /library/purpose helper tools. All right, and then I think there's one more of interest. So this is called Pixar RenderMan, and this utilizes an old C API. I'm going to spend just another second or two going over this because if you're going home and looking at some of these privilege helper tools, you might come across some that utilize an older C-based API rather than the Objective-C-based API. This is what it looks like. Towards the middle there, this is similar to the client I showed you previously. We have the set in N64, set strings with strict dictionary typing, and you just pass the information similar to that. And here is the one that launches the temp/root.py. Notice it literally takes argv from the user, just as if it was calling it right in the main, and sends it directly to execve. Okay, and now here's the variant analysis topic one more time. We got a patch. They don't reach out to us to ask if the patch is okay. They just say, hey, I can handle it. And the patch is incorrect. And what it does is it allows you to install packages, which I thought was relatively interesting. This is what a package is on OSX. It breaks out into these things. And if you notice all the way on the right, it says scripts, pre-install and post-install. And so if you use this package creation tool at the bottom here, you can actually create packages with arbitrary scripts. Oops. So just to give you an example of what that looks like. So that's the expansion of the package, and then going to scripts, you see the install scripts, and if we do the same thing, you notice I just put the install script as myself. Okay. Now we're listening again. And first, I'm just going to install a package. So this is like, I put this in here as an example of why you should never install arbitrary packages, why you should never allow somebody to arbitrarily run commands on your program, on your system. So if you download, say, a torrent of Photoshop or something, this is how easy it would be to take advantage of your computer. You type continue, you type install, put your password in, and you say, hey, I'm installing Photoshop, look at me. And then, now this guy has, now I have a root listening shell. Yay. And so this is just, I put this in here more as just a warning, an example that, of what these can do. And I would highly recommend utilizing this package expand before you install any packages or that are not verified. And so notice it comes directly from the system, install D, and is ran directly from Python. Okay. Now I have this, the same thing as before, except now instead of calling argv with just direct arguments, it passes them directly into package install, which requires you pass in some specific information, and then /temp/root.package. Let's set that up real quick before I. So root.pkg, put that in there, and then open a new terminal, listen, and execute this. And again, who am I? This is getting old, right? And then back one more, we see this comes directly from install D, which got called directly out from Pixar. And so this is an example of the variant analysis, and for our team and our company, we always will work with the vendors directly to help support them and ensure that they are able to get the best patches out as possible. But many times, this vendor in particular will yell at you and they'll tell you they don't like you and they tell you that you should stop looking at their programs and they tell you to leave them alone. And so what I do, I went and I found these vulnerabilities to send them back. Okay? All right. And we got one more issue that came up. And that's with this tool called Popcorn Time. Maybe somebody's heard of it. It's a Russian tool that came out, or it's hosted on Russian domains. And this tool is just the worst tool you've ever seen in your life. It downloads and streams torrents as 100% as root. I don't have it installed on my system anymore because I was scared when I saw it. It doesn't follow any guidelines. It doesn't use any application. It doesn't use any Apple code whatsoever. No Objective-C, no XPC, none of that stuff. So I'm assuming that it's a build for Linux or something of that nature and just port it over. It spawns a Node.js web server that accepts connections on like 5 ports, accepting arbitrary commands. It persists after uninstall. I wouldn't even believe it if it didn't happen to me. You uninstall the application and it reinstalls a new application called PT. Instead of Popcorn Time, it's called PT. I then did some basic fuzzing on it. You can directly get a program counter control, which is the most simple fuzzing. And if you look up online, other people are talking about this application, but it's widely used. I found it on at least 10 or 15 computers at work, and I'm pretty much 100% positive it's just a backdoor. It's just sitting there as root, accepting network connections on your system. Okay? And so helper tools, they listen as root, and they communicate over cross-bus communication. They persist even after uninstall. I don't mean persisting as in a malware type tool. I mean literally if you do not go into launchd and say unregister, then you did not actually uninstall the application. And so if you get an update or something, you must update launchd as well. And many are not following the correct Apple coding guidelines or not following them at all. Okay, and so as Apple continues to progress, they're moving towards Swift. I have not had time to locate, to get the communications up in Swift, and I would really like it if anybody else would be interested in working on it with me or would want to dive into it. I have at least 3 programs I've seen already that have these same exact issues, no authentication, no authorization, just CVs waiting to have your name on them. So I put all this up on GitHub, and I included a little thing called check helpers. It just runs and compares your helpers versus the ones I've already looked at. I will show you that real quick. So here is a list of all of the, here's a list of all the helpers I've looked at and their status. And so you can look at these here, and I even put one in Swift that has vulnerabilities in it just for fun, just in case you wanted to go find them yourself. And notice these guys are awaiting patches. You can go download the latest version yourself. That's all 0 day. It's all ready to go right now. I also posted up any one of these ones that, all these have a waiting patch as well. Anyone that doesn't, that's already patched, I posted up the vulnerable client, the vulnerable installer on GitHub as well, so you can test them out yourself. I then have a couple pieces of information that you can go back over, essentially telling you how to find these and what you should do when you do find them, searching for the should accept new connection. This is mostly for looking at after the talk. All right, and I got 15 minutes of extra time. I didn't realize I had so much extra time. I kind of blazed through all this a little faster than I thought. Does anybody have any questions or comments, concerns? I would love to, if anybody wants to see more Objective-C reverse engineering, I guess I have plenty of time. I guess I could, unless you have questions. Rich?
Yeah, just one quick question, because I don't use OSX, but when you install an application, it doesn't normally have root privileges to install arbitrary locations and stuff like that, right? So we were showing
I'll show you how that comes about. So right here, you're going to see this. This is what it's going to look like when something tries to install this new, this helper tool, as they call it, that will listen arbitrarily. So typically, when you install something, if you do type your password in, this also could say renderman installer is trying to make changes. And that also, making changes also can mean installing helper tools. But if you're using Apple's provided guidelines, they're specifically supposed to tell you when they're doing it, but they don't always do that. You can install apps, but not these apps. Exactly. As I showed you with the demo user, I was able to install Shimo, but not, but the root privilege helper was already there.
More questions? Yes.
While I'm answering these questions, I'm just going to pop IDA open and multitask.
Thank you for your presentation. Have you all your demos were on OSX, obviously, it's easier to show. Did you check on iOS?
So iOS does not have, I tried to mention that at the beginning, but iOS does not have the same functionalities that OSX does. If you check out the cross-process communication slide, I specifically mentioned here that iOS uses the Grand Central Dispatch as their main inter-process communication mechanism, and they do not allow, it's even more privilege isolated than OSX, and they do not allow third-party applications to have root whatsoever.
More questions? Yeah.
Not really a question, but maybe a tip for people looking at stuff like this. If you don't want to spend a lot of money on IDA or Hopper, you just can use class dump to dump the protocol of the privileged helper tool. You can more or less, you can even automate this stuff. Another thing, if you want to check out how the services are communicating, use Frida, because some of the especially VPN clients try to hide those vulnerabilities by using some weird protocol, and then you can uncover this really easy with Frida. I think I've looked at 5 VPN clients, 4 of them were vulnerable, and only one vendor would fix the issue. The other one, really, they don't care.
As I said, I believe every OpenVPN client utilizes similar functionalities to that.
Okay, somebody else?
You said something about auditing packages before installing them, something about expanding.
Auditing packages.
Yeah.
So what I mean by that is you go to a package, packages, oh, they're right here, never mind. And you just type package util expand, and that's going to give you this extra directory, pkg, this extra con directory, and then here you have all the information. BOM is a bill of materials, I think it's, so it's package info is an XML-based version of that, and so you see all the different things, and then you can easily drop those pre and post installs into IDA, or you can, in this particular case, they are just Python scripts. And so you'll quickly see it's Python script, text executable. And so if I would have given this to you, I could say, hey, I'm your best friend, and you would install it. But you could have just quickly checked and said, hey, that's an executable. Let me see what's going on with that. That. You can see. Okay, like I was saying, so this is init with mock service name. You can follow that along. You could also follow interface with protocol, as our friend was saying. You could even do something like a strings dump or something of that nature. to get into these, where these interface and protocols actually happen. But notice it's on should accept new connection. We have our protocol that I was telling you about. You follow it around. You get to the methods right there. And then back in the hex arrays. Yeah, and then from those methods, you can click any of them to get yourself around. In this particular instance, the vulnerability was in start process. And here's the two start processes. And it calls in here. And as I showed, this was directly in the slides, but notice they call it start with dict on this area, and this is your v3 is your functionality, but it has to be an existing process.
Just a small addition, because you talked about expanding packages. For those who are not so fancy with the console, there's also a nice tool which is called suspicious package, which you can right-click, open package, and then you see the certificate and all the info as well in there. Yeah, just check it out.
Yeah, it's definitely highly recommended to be verifying your programs before installing, whether it's through hash signatures or package expansions. All right, so I'm going to post this on Twitter, and I would appreciate it if you just would run your command. If you come up with any new helpers, send me a pull request. If you don't have time to look at them, just say, I didn't have time to look at them, and send them over. And we're just going to start compiling a long list of all these privileged helpers, and we're going to get rid of these. We're going to get rid of these issues. We're going to figure it out once and for all. So just keep, if you guys would just even retweet it for me to get more people out there to start getting rid of these things, because I don't want root listening services on my computer. That's how this started. I have this was on my personal computer, and so I don't like that to happen to me, and I know nobody else likes it to happen to them. And so I would appreciate your help in getting it taken care of.
Okay, if there's no more questions, then let's have another round of applause.